Let's now do an example using this washer method. So if we have a solid that generated from the resulting of this figure being rotated around the x-axis, let's find the volume. So we can see that the left boundary point will be 0. However, we do need to figure out what the right one is. So we have x equal to 2 minus x squared. This gives us x squared plus x minus 2 equal to 0. So x plus 2, x minus 1. And so we can see that we get x equal to negative 2 and 1. So we can see that this one comes from the 1. So I have the integral from 0 to 1. Pi times my top function, which will be 2 minus x squared, squared minus the bottom function squared, so minus x squared. We can pull the pi to the front of the integral, and this gives us 4 minus 4x plus x squared minus x squared dx. So pi times the integral from 0 to 1 of 4 minus 4x dx. This gives us 4x minus 2x squared going from 0 to 1 all times pi. So as we evaluate this, I have 4 times 1 minus 2 times 1 squared minus 4 times 0 minus 2 times 0 squared, which we get to just be 2 pi. So this also works if we want to rotate around the y-axis rather than the x-axis. The only difference is we'll need to integrate with respect to y. So we will need to have our equations as x equal to our functions, and then we can integrate with respect to y. So for example, let's consider this volume of a solid obtained by rotating the portion of the region bounded by the cube root of x and y equal to x equal to 4, x over 4, that lies in the first quadrant about the y-axis. So I'm only considering the first quadrant. So here's the cube root of x, and here's x over 4. So I'm considering this region here. I need to know the boundary points. So we have the cube root of x is equal to x over 4. We can multiply both sides by 4 to get rid of the fraction, and then cube both sides to get rid of the root, get everything on one side, and factor. So I get 0 is equal to x times x squared minus 64. So we have x equal to 0, and x squared is equal to 64, which would give us that x is equal to plus or minus 8. Since I'm only considering the first quadrant, we only need to consider 0 and 8. So now we have the x values. However, when we do our integration, we need y values. So if x is 0, we can see that y is 8, or y is 0. And if x is 8, we can see that y is 2. So we'll integrate between 0 and 2. Since our actual intersection points are 0, 0, and 8, 2. We then need to do pi times the left function squared. So the left function is y equal to x over 4. To solve for x, we will multiply both sides by 4 and get 4y equal to x. So we have 4y squared minus the right function squared. The right function is y equal to the cube root of x. To solve for x, we can cube both sides. That gives us y cubed is equal to x. So we have minus y cubed squared dy. So this is the integral from 0 to 2. We can pull the pi out front, and then we have 16y squared minus y to the 6th dy. So this gives us 16 over 3 y cubed minus 1 over 7 y to the 7th, evaluated between 0 and 2. So we have 16 over 3 times 2 cubed minus 1 over 7 times 2 to the 7th minus 0. And once we simplify this, we get 512 pi over 21.